So coming to the next question, that is there is a you have to tell that correct statement. Okay. So first one is the two complex are given and you have to tell which statement is correct. Uh, just read the statement. Say it about the bond length of the CO and CO means when it is forming OH2. You can see the ligand is OH2 in every in both complex, and they are discussing about the metal and oxygen bond length. Okay, and mainly they are asking about the in which complex the equatorial bond length and the axial bond length will differ, and in which complex it will be equal. It's like that. So the question is based on the concept of the John Taylor distortion. Let us first take the complex, that is nickel H2O whole 6 2 plus, and another is Cu H2O whole 6 2 plus. So both the complex has water ligand. So we will focus the electronic configuration or the d orbital configuration of the complex. So directly let's go to the nickel 2 plus, that is nickel is the 4s2 3d8 system, and for nickel 2 plus it is 3d8 system, that will be like this. So it is a symmetrical configuration, electronic configuration. So there so it is a symmetrical configuration. So no John Taylor distortion. John Taylor. Here the Cu2 plus, Cu2 plus Cu has 4s2 3d9, and the here is the configuration is T2G6. I am not writing this thing. It is T2G. It is easy. You know this thing. This is T2G. This is easy, and 3 electrons here. So you can see that Eg has unsymmetrical filling of electron, unsymmetrical electronic configuration, that will show strong John Taylor, strong strong dynamic John Taylor distortion. So what will happen for this John Taylor distortion, and what will happen for no effect of the John Taylor distortion? So the complex will be like this, means the Ni OH2 bond means these bonds means NiO bonds will be equal in both axial and equatorial positions. But for this Cu complex, as unsymmetrical configuration in Eg, it will show elongation in the axial bonds. So the axial bonds will be elongated compared to the equatorial bond. So we can easily detect it through spectroscopy, that is IR spectroscopy bond strength. This bond length will be longer, axial bond length will be greater than equatorial bond length, and we can know this through spectroscopy, studying spectroscopy data. So find the correct option for this. So NiO bonds are equal, whereas equatorial bonds are shorter than Cu axial bonds. Same thing is written here. So this will be the answer. So coming to the next question. You have to tell that this is a normal spinal or inverse spinal. This is a very easy question. So before solving this, we will see that it is the AB2O4, and how we will calculate that. We take A3 plus and B2 plus. So if that is normal spinal, it will occupy the octahedral void, and it will occupy the tetrahedral void. Now how to calculate this? If the 3 plus oxidation state of the metal, means here Mn or A3 plus, has higher CFSE, crystal field stabilization energy, than B2 plus, then it will be normal spinal. If the reverse is happen, then it will be inverse spinal. So for this case, it is Mn3 plus and Cr2 plus is present here. Uh, sorry for the wrong statement, means here, let me correct this. This will be 2 plus, this will be 2 plus, and this will be 3 plus. This, the whole concept is reversed, means B3 plus should have gotten CFSE, then A2 plus. Because it will be B2O3 and AO, okay, and then it will be normal spinal. And if the reverse will happen, means B3 plus CFSE is less than A2 plus CFSE, then it will be inverse. Okay. So for this, here Mn Cr2O4 complex is present, means spinal is present, that is Mn2 plus and Cr3 plus. We have to see the configuration and we have to calculate the CFSE and compare the CFSE. So for Mn2 plus, it is a D5 system, and for Cr3 plus, you know, this is a, what is the configuration of Cr3 plus, that is 4s2 3d, sorry, 4s1 3d5 and 3 plus is there, so 3d3. So D3 system is present. So as you can see, it is a Mn2 plus D5 system, the CFSE will be 0. For D5 system and D10 system, the CFSE is 0. So and here is minus 1.2 delta, means 3 electrons are there, into 0.4 delta. Okay. So it's already, you can see that CFSE it is 0 and it is has some energy, it has some CFSE it has. So the 3 plus, means Cr3 plus CFSE is greater than Mn2 plus, so it is a normal spinal. The conclusion is it is a normal spinal. Then what is the conclusion? That all the CR3 plus will occupy the octahedral voids, all, and the all uh, Mn2 plus will occupy the tetrahedral voids. This is the conclusion. Okay, I think you understand. So coming to the next question. So coming to the next question, that it is a very important question, because not only I will solve this, I will give you some short notes about it. Many things you will get to know. Just stay with me till the end. Here you can see that spin only magnetic moment and the spectroscopic ground state term symbol you have to evaluate of this complex. So there is a long process of we can calculate easily the spin only magnetic moment by calculating the unpaired electrons, means the value of n, mu s equal to root over of n plus 2. So we can easily calculate the unpaired electron by watching the electronic configuration. But for the term symbol or for the Mulliken symbol, if means not given in the here in the question Mulliken symbol, but if they ask Mulliken symbol, so how will means how will evaluate these things? I will give some short tricks to evaluate this, but there is a long term. You have to go for the electronic configuration, and you have to calculate the L, the 2s plus 1 value. Then you have to write 2s plus 1 plus L into J. This is the term symbol. So let's do it, and I'll tell you accordingly. So this is the complex is Mn if if6 3 minus, that is Mn 3 plus. So Mn we know the electronic configuration is 4s2 3d5. So Mn 3 plus is 3d4. So the electronic configuration will be d4 high spin, as the fluorine is there. So the number of unpaired electrons is 4. As I told in this, as I told that if the number is 4, so the spin only magnetic moment is 4 into 4 plus 2. So in I think previous video I told the how to calculate without using the calculator the value of this. You can see the video. I will provide the link in the I bottle. You can go to the first part of this. So here means it is nearly equal to 4.8 to 4.9. I didn't mention here the options, because if I give options you will try to find between the options, you will not use your mind. So that's why I eliminated the options. During practice don't means compare the options, only focus on the questions and use your thinking ability. So here the answer will be like this. Means I told some tricks to remember how to remind the values of the uh, means unpaired electrons and the magnetic moment value or for the different unpaired electrons. In the previous video you can go to the video with the link is given in the I button. Okay, so now the normal rule to evaluate the term symbol is like fill the electrons in the d orbitals, means here plus 2 plus 1 0 minus 1 minus 2. So here the total s value is 4 into half, that is 2. So the 2s plus 1 value is the 2 into 2 plus 1, that is 5. L value is the, so minus 1 minus plus 1 cancel 0, this is equal to plus 2, that is SPD. So the 2s plus 1 L is 5D. So this is the thing long process, and as this is less than half filled, it is L minus S. J value will be L minus S. So it will be L value is 2, S value is 2, so it will be 0. So the total term symbol is 2s plus 1. 2s plus 1 is 5. This is D, and this is 0. So this will be the term symbol. Now let me introduce some short trick here. You can note these things in your notebook as well. Just write like this: D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. So how to remember the term symbols? Like here, there is a means short term like use like this, means n plus 1. Use n plus 1. N means the unpaired electron. N means always unpaired electron. So here unpaired electron is 1, means the n plus 1 value will be 2. So it will be like this: D F F D, then S, again D F F D, again S. So you can see from D1, D1 is D, DFFD, DFFD S. So you have to remember like this: DFFD, DFFD. So for D1 it will be like 2D, it is 3F, it is 4F. Understand? I think this is the how I am getting this value. This is from the unpaired electron plus 1. Unpaired electron is 2, so the value is here 3. And this is for the high spin system. Okay, high spin system, the it depends on the number of unpaired electrons, but the term symbol will be same. Means if if it is a low spin, the this system will differ, means d4 system will become, means the unpaired electrons become 2, but the this term will be same for dffd and dffd. Just change the value will change for the n plus 1, because the number of unpaired electron is changing. So here 5d, so here 6s, means 5 unpaired electron and the term is s, so 6s. Similarly for 5d, 4f, 3f, 2d. Okay, and this is 1s, no unpaired electron is present here. So just remember this thing: dffds, dffds, and add the here n plus 1. In what is n? N is the unpaired number of the unpaired electron. This is how you can this is how you can evaluate the Mullikan, not Mullikan, term symbols. Term symbols, Mullikan term symbols you can write. Term symbols. Now there is some spectroscopic term symbols. I'll teach you this lesson as well. That means how to evaluate the spectroscopic term symbol. In this video, I'll just tell you. Just wait. Here again write the thing, that is D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. Wait for a few minutes. Let me write another thing. Here you can see that octahedral is like this. Uh, okay, so take it as T2G. This is T1G. Just don't question, just listen to me. You will understand everything. And here is easy. This is A1G. Just remember this orbitals. I know this is a T2G orbitals and this is EG orbitals. But how we will evaluate the spectroscopic term symbol from it? As I told that you have to take n plus 1 again. What is n? N is the unpaired electron. Remember this thing. So what will happen for D1 system? The electron will be here. So we will take this T2G term here, and as I told n plus 1 we have to put, so 2. So the spectroscopic term symbol of D1 will be 2. That's that much easy it is. Okay, same thing we'll do D2 system. Means what will happen here, like this. Means for D2 this is the configuration, and I will take this thing T1G. So I will write T1G, and what we have to take n plus 1. What is n? N is the unpaired electron. So 2 plus 1 equal to 3. So this is the term symbol for D2. It's that much of simple. Okay, for like that, here the unpaired electron is 3. Here D3 will come. So A2G term we will take. Okay, and the number of unpaired electron is 4. So this is the term symbol. This is the spectroscopic term. Same thing if we take for 7. Let's do some different thing. 7 means last. You have to see the filling of the last electron. Means D7 means this is D5, this is D6, and this is D7. Means last electron coming to the T2 T1G orbital. So we'll take the T1G orbital. Okay, we'll take the T1G orbital, and the number of unpaired electron is 3. So n plus 1 equal to 4. N plus 1 equal to 4. Understand? I think this is the spectroscopic terms. Here unpaired electron is 3. So 3 plus 1 equal to 4. The unpaired electron is here, and the last electron filling is here. So T1G will be the term. So this is that much of easy. And for D6 again, comment it how. Just pause the video and make it yourself. Just solve it yourself. What will be the term symbol of this D6? Pause the video and do it by yourself. So I am writing again D6 system, the last electron is filling in here. So the term we will take, that is T2G, and the number of unpaired electrons are 4. So the value here will be 4 plus 1 equal to 5. 5 T2G will be the term symbol. So that much of easy. So these are the things how to solve, how to evaluate the spectroscopic term symbols. And before I told how to evaluate the how to evaluate the Mulliken term symbol. So this is the process, short tricks I follow. Okay, so without wasting any time, coming to the next question, the last question of this series. So you can see that here they are asking about the orbital contribution to the magnetic moment. You know that there is a two things, that mu effective and mu spin only. So when the orbital contribution is added to the magnetic moment, the mu effective is greater than mu SO, and the formula is mu effective. You know that I am reminding again, that is mu SO, mu spin only, 1 minus alpha lambda by delta. Okay, and the value of lambda is positive for the less than half field and negative for the more than half fields. Okay, so that is not the issue. The issue is we have to just calculate the which means not calculate, we have to see the which options, which complex have the orbital contribution. So for that we have to see the electronic configuration of every complex. So here Cu2 plus, here Ni2 plus, and here CO2 plus, and here Cr2 plus. So for COT plus, you know that this is a D9 system, 3D9 system. It will be like this. And here no exchangeable T2G orbitals are present. Orbital contribution means what? There will be T2G exchangeable orbitals should be there. So here also means D8 system. It will be like this. This is a 3D8 system, and here CO2 plus D7 system, and Cr2 plus. Cr2 plus means D4. Okay. So you can see here is no exchangeable T2G orbital is present. Here is also no exchangeable T2G orbital is present. Here you can see that we can exchange these electrons here, and means T2G orbitals are exchangeable, so orbitals are exchangeable. So this is orbit. It has orbital contribution actually. It has orbital contribution. Let's see here. Here is also we can't exchange here, because if we change exchange here, it will lost its means it will be spin forbidden and orbital forbidden as well. So it is not present. Only this D7 system has that orbital exchangeable probability. Means orbital contribution is what? If we can exchange the T2G orbital, okay, means dxy is exchangeable with dxz, dxy exchangeable is dyz, and dxz exchangeable is dyz. If it is happens, the orbital contributions will contribute. Orbital contribution. So this is happening only for the D7 system of given here. So it will have only the orbital contribution here. So the answer will be here. So this is the last question of this video of the coordination chemistry series. You can see the first part of this video. I will put the link in the description or in the I button. You can check. So I think if you want more questions from coordination chemistry, you can comment below. I will try to make videos, because it is difficult to means put very few questions from a chapter, but I will try to make. If you want any questions from another chapter as well, you can comment below. I will try to. Thank you for staying with me till the end. Have a nice day.